The sum and product properties consist of 8 properties. The 4 on the left are product to sum, and the 4 on the right are sum to product. The product to sum identities are used to rewrite the product between sines and cosines into a sum or difference, while the sum to product identities are the reverse of the product to sum identities and are used to rewrite the sum or difference of sines and cosines as a product. All of the variables represent an angle measurement and can be used in degrees or radians.
So for the proof of sum to product, we have cosine x plus cosine y equals 2 cosine 1/2 x plus y cosine 1/2 x minus y. And then we can assign variables for x and y, so x equals a plus b and y equals a minus b. And then by using the composite argument properties, we can say that cosine a plus b equals cosine of a cosine of b minus sine a sine b, and cosine a minus b equals cosine a cosine b plus sine a sine b. And then we can add those two equations together, so we have cosine of a plus b plus cosine of a minus b equals cosine a cosine b minus sine a sine b plus cosine a cosine b plus sine a sine b. And then we can simplify that into 2 cosine a cosine b. And then we can add the equations and combine them, so a plus b equals x and a minus b equals y. We can add those together so the b's will cancel, and we are left with 2a equals x plus y and a equals x plus y divided by 2. And then we can subtract those two equations so that the a's will cancel, and we are left with 2b equals x minus y and b equals x minus y divided by 2. And then we can put those back into the equation, and we are left with cosine of x plus cosine of y equals 2 cosine x plus y divided by 2 cosine x minus y divided by 2.
For the proof of product to sum, we start with 2 cosine a cosine b equals cosine a plus b plus cosine a minus b. Starting on the right side, we can use the composite argument properties to turn cosine a plus b into cosine a cosine b plus sine a sine b, and turn cosine a minus b into cosine a cosine b minus sine a sine b. When we put them back into the equation, we get cosine a cosine b plus sine a sine b plus cosine a cosine b minus sine a sine b. The positive and negative sine a sine b's cancel out, and we're left with cosine a cosine b plus cosine a cosine b, which simplifies to 2 cosine a cosine b.
Put these on like this.
Now for an example of product to sum, we have 2 cosine 53 degrees, cosine 49 degrees, and we are trying to rewrite that into a sum. So a is 55 degrees and b is 49 degrees, and by using the proof that we have already solved, we can rewrite that into cosine of 53 plus 49 plus cosine 53 minus 49 degrees. And we are left with cosine 102 degrees plus cosine 4 degrees. Now for an example of sum to product, we have sine of 3x minus sine of 8x. So a equals 3x and b equals 8x, and by using the property sum and product, we have 2 cosine 1/2 3x plus 8x sine 1/2 3x minus 8x. We can then further simplify that into 2 cosine 1/2 11x sine 1/2 negative 5x. And then we can distribute that 1/2, so it looks like 2 cosine 11x divided by 2 sine negative 5x divided by 2. Then by using the even and odd property, we can take that minus sign and move it to the outside equation, and we are left with negative 2 cosine 11x divided by 2 sine of 5x divided by 2.
Now this one is a try on your own example. Turn 2 cosine 85 cosine 28 into a sum. Now go try on your own. To turn 2 cosine 85 cosine 28 into a sum, assign a to 85 and b to 28. Then use the product to sum property, which will give you cosine 85 plus 28 plus cosine 85 minus 28. This then simplifies to cosine 103 plus cosine 57.